When we Eulerize our graph, we have two different situations or scenarios we might see. The first one is that the two odd vertices are connected by the same edge, or the odd vertices are not connected directly by the same edge. And depending on which ones you have will change how you do your duplicating of the edges. The thing I like to do is start with identifying the degree for each vertice. And I see that I have 4 vertexes that have an odd degree. And so I want to duplicate edges so that those become even. And all of my odd vertices are connected by an edge. And so I can duplicate these edges in however ways I want to try to Eulerize it. So if I duplicate it like this, I get 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's 5. So that's not a good option there. So let's erase this one. And 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now we have 4 vertices for everything, and we can try to create our Euler path from there, starting at 1 vertice and trying to get everywhere. That's not going to get us to where we want to go, but there we go. We started at the center and went back to the center, creating our Euler circuit. So we'll do that again with this graph here. We are going to start by counting our degrees for each vertex. We have 2 vertices that have odd degree, and in this case they are connected. So we can go ahead and connect those with another edge. And now it is Eulerized because these are now degree 4, degree 4. And we can create our circuit. Let's see. We can try this here, creating our circuit. So let's Eulerize this one. Once again, we'll start with identifying the degree of each vertex. We have 3 odd. And we want to connect them, the 2 3s, but they're not directly connected, and we cannot create a new line. Think of this as if it were a map of a neighborhood where each edge represents a road and each dot represents a house. You're trying to get from house B to house E. Say you're delivering mail or something, and we want to go from B to E, but the mail truck can't just drive through people's yards to get from point A to point B, or in this case, point B to point E. They need to go through roads. Whatever roads they need to go through it. And so in the Euler circuit, they want to get to around every edge with no repeats. But in this case, we're going from B to E to turn those into even by duplicating. So if I duplicate this to make it a 4, this turns into a 5. And now that is odd. But you'll notice now we have 2 odds side by side, which means I can now go and duplicate those, making the 5 a 6 and the 3 a 4. And now we have all even vertices, and it is Eulerized.